First, let's look at our learning target for lesson 8 here. It says, I can decide if a relationship represented by an equation is proportional or not. So the key factor is we're going to be looking at equations and deciding whether they are proportional or whether they are not. Remember, an equation that we've been using thus far is y is equal to kx, where k represents our constant of proportionality. So that's really important. If we don't have a constant of proportionality, we cannot have an equation. Let's take a look at 8.3 here. 8.3, total edge length, surface area, and volume. Here are some cubes with different side lengths. Complete each table and be prepared to explain your reasoning. So let's look at all three tables. We have a cube, side length 3, a cube with side length 5, and one with 9.5. One says, how long is the total edge length? So we're looking for the total edge length there. Then 2 is, what is the surface area of each cube? We have a list to compile. And our third one on the next page is, what is the volume of each cube? Then on 4 it says, which of these relationships is proportional? And explain how you know. And 5 says, write equations for the total edge length E, total surface area A, and the volume V. So we're actually going to start that with side lengths S. Okay, so we're going to look at total edge length first. Now we think, how many edges does a cube have? Well, if I think about this first, we've got 1, 2, 3, 4 edges on the front side, 1, 2, 3, 4 going around, and then 4 on the back. So that's a total of 12. So there are 12 edges. I'm going to write that down. 12 edges on a cube. So once we know the side length, we simply multiply it by 12. So for this table, we're going to multiply 3 times 12. That'll give us 36. 5 times 12, that'll be 60. 9.5 times 12, 9.5 times 12 is 114. And if we had side length S, that's simply going to be 12S, 12 times S. Let's go ahead and look at the surface area of each cube. Before we do the surface area, we got to count how many sides does a cube have. Well, we have a front and a back and 4 along the lateral sides. So that's a total of 6 sides. 6 sides. And we're looking for the total area. So remember, area of a square, because each side is a square, we have an area is going to be the side length squared, but we have 6 of them, so I'm going to use 6s squared. That's what we're going to do. So we're going to take our side length, square it, and multiply it by 6. So I'm going to write this over here. It's going to be 6 times 3 squared. So remember, 6 times 3 squared means that's 6 times 3 times 3. We're multiplying 3 by itself twice. Don't get that confused with 3 times 2. So we have 6 times 3 is 18, and 18 times 3 should give me 54, and it does. So we have 54 here. Next one, we're going to have 6 times 5 squared. 5 squared is 25, and 25 times 6, like 6 quarters, is $1.50 or 150. 9.5 squared times 6, that's going to be 541.5. And if we just have the side lengths, again, we've already kind of got that written down, it's 6s squared. We've got our first 2 tables done, how long are the edges and surface area. Now we're going to work on the volume. So let's go back up to our picture and think about what volume means. Volume is the space that is contained within those things. So the volume of any rectangular pyramid is length times width times height. But since we have a square cube, the length, the width, and the height are all the same. So we're just going to say the volume is going to be the side length cubed or multiplied by itself 3 times. So cube each one of those numbers. We'll go back to our table and fill that in. So our volume is going to be 3 cubed, 5 cubed, 9.5 cubed. So I'm just putting the power of 3 on each of these. So remember, 3 cubed means 3 times 3 times 3. That's going to be 9 times 3 or 27. 5 cubed is 5 times 5 times 5. 25 times 5 is 125. 9.5 cubed I'm going to do that 3 times my calculator. 9.5 times 9.5 times 9.5. And I get 857.375. And then if we just had side length, we call that S cubed. So we have our 3 tables filled out. The total edge length, surface area, and the volume. It says which of these relationships is proportional. Explain how you know. So we're going to do a y over x scenario in each one of these. For our first one, we have total edge length over the side length. If I do 36 divided by 3, it'll give me 12. 60 over 5 gives me 12. 114 over 9.5 is 12. And this makes sense because we multiplied by 12 to get those numbers. So when you divide them, you're going to get 12 back out. So this is proportional. The first one is, so I'm going to write proportional. Let's look at the area. We have 54 divided by 3. Now 54 divided by 3, that's going to give me 18. And then we have 150 divided by 5. And I can see real quick here, 150 divided by 5 is going to give me 30. Once I see these two numbers are different, we do not have a constant of proportionality. They're different. So it's not proportional. We could have kept going, but there's no reason to. Once you see that they're different, it's not proportional. Now let's look at our volume. We're going to take what's in this second column divided by the first, so it's going to be 27 divided by 3 is 9. 125 divided by 5 is going to be 25. So right away, we can see we don't have a constant proportionality because these two numbers, 9 and 25, are different. So that's not proportional. Not proportional. So as which of these relationships is? It was our first one, the edge length. So we go up here, that was proportional, it is the edge length. That was proportional because we just multiplied all the sides 12 times. It says write equations for the total edge length E, total surface area A, and volume V. So let's go back and kind of write these. I'll write them down here first. And we have 12 edges, so the edge length was simply 12 times the side. And then we have the total surface area. I'm going to put SA for surface area. Let's look back on how we calculate that. We did 6S squared. The area equals 6 times the side length squared. 6S squared equaled the area, the total surface area. And our last one, we have volume. That's the interior space of the cube. We just did the side length times itself 3 times. So the volume equaled S cubed. And I want to quickly analyze these 3 equations. Notice E equals 12 times S. This is the only one that's in the form y is equal to kx. In the second one and the third one, we have an S squared and an S cubed. When you have area and volume, those are not proportional. That's the key thing to know. Area and volume are not proportional to scale factor.